Okay, learners. So for this week, we'll be looking at elements in the periodic table. And we have different elements in the periodic table. We have metals, we have non-metals, we have semi-metals, also known as metalloids. So that is what you have here. Right, so in this lesson, we'll be looking at each of these group of elements. So we'll look at metals in detail, we'll look at non-metals in detail, and we'll also look at semi-metals or metalloids in detail. To understand this topic well, you need to have a good knowledge of the periodic table. So I will show you a copy of the periodic table here. So this is a copy of the periodic table. Here to the left, you have elements in group 1. You can see here the right one on top. That means that the element in this block, in this vertical block, so those elements belong to group 1. Then here in this second vertical block, all the elements in this second vertical block are said to be in group 2. So this is group 2 element, right? So now let's look at other groups. And before we go to other groups, it's important to note that most of the elements in this group 1 and 2, they are metals. The only exception here is hydrogen. Hydrogen behaves in a funny way. Sometimes it behaves as a metal, and sometimes it behaves as a non-metal. So this is group 1. So let's call this group 1. The element in this block belong to group 1. Then the element in this second vertical block are said to be in group 2. Then forget this group 3 group. This one, this block of elements is said to be transition element. From here to this place. So these ones are called transition element. Transition elements. Sometimes you call them transition metals, right? So now the grouping continues here. So here you have group 3, but here they said it's group 13. Never mind, this is group 3. So here I will just use G for group. This will be group 4. This will be group 5. So the element in this block, in this vertical block, will be group 3. The element here will be group 4. The element here will be group 5. Then the element here will be group 6 in this vertical block. And the element here will be group 7. The element here in this last vertical block will be group 8. So that is the standard way to name the periodic table. And remember, the element in these rectangular block here are called transition element or metals. Now, this one, the lanthanide and the actinide, you don't need to understand this one at your level, so we'll leave it out for further discussion, right? So you need to have very good knowledge. So, like I said a moment ago, the elements to the left of your periodic table, elements in group 1 and elements in group 2, they are metals. As we move on in the lesson, we'll look at the characteristics of metals. Now, after the transition element, we see here that we have this, right? So This element, the element in this diagonal block, are metalloids. They are semi-metals, right? This element here, they are semi-metals. They are metalloids. So it means that they can behave both as metal and non-metals. Let me look at it properly. Okay. Let me, so I don't confuse you guys. Okay. Okay. So the element in this vertical block, in this diagonal block, colored light blue, or is it colored blue? This one is colored blue. Those are semi-metals, right? Aluminium is classified as a metal. And the elements to the right, yeah, carbon, nitrogen, oxygen, phosphorus, sulfur, selenium, fluorine, chlorine, bromine, iodine, and so on. All these ones are non-metals, right? So the one, remember again, the one in this blue color, right? They are metalloids or semi-metals. So it means that they can behave as metals and they can also behave as non-metals. So it's important for you to understand those characteristics. So as we move on in this lesson, so you can see various examples of substances here. So these this aluminium and copper, they are pure metals, they are pure elements. But when you have brass, bronze, and steel, so these three, bronze, brass, and steel, they are what we call alloys. Alloys. Right. So with time, I will tell you what alloys are. Right. So alloys is the mixture of two or more metals, right, in order to form a substance with desirable qualities. For example, brass comprises copper and tin, right? Brass comprises copper and tin. Then bronze comprises copper and I think I'm not mixing things up now. So brass is a mixture of copper and one other element. I believe it will be copper and tin. Then brass is a mixture of copper and zinc. Then steel is a mixture of iron and carbon. So when you have the mixture of a metal with another metal, or a mixture of a metal and another substance, then that would give you alloys, right? So that is that. So yeah. So we look at the physical properties of the element, right? Remember, the elements are grouped into three categories. The first category is metals, then the second category is non-metals, and the third category is semi-metals, right? So we will look at the physical characteristic. So what is a physical characteristic? It's a characteristic that one can observe or measure with sense organs without changing the substance into another substance. For example, the hardness of a substance, the brightness of a substance, the ability to beat substance into different shapes. Those are the things that we can see physically and we can achieve with physical effort, right? So those would be the physical properties. Now, we would also look at chemical properties. And chemical properties deals with characteristics that may only be observed through chemical reaction. An element's chemical properties determine how the element combines with other elements, e.g. during rusting. So during rusting, iron combines with air, oxygen to be specific, right? And when you have oxygen combining, when you combine oxygen with iron, then that forms a chemical product known as rust. So yeah, so as time goes on, we see and we learn to identify where iron and oxygen occur in the periodic table. All right, so you can pause the video now and look on your periodic table and locate the position of iron and oxygen. Now, chemical reaction. A chemical reaction is a process by which one or more substances change to produce one or more different substances. A very good example is what we have seen in the previous point. Iron, for example, is a pure metal, is a metal. So when you react iron with oxygen and moisture, for example, a new substance known as rust is formed. And you see the property of rust is way different from that of iron and oxygen. Right. So let's look at some properties of metals, non-metals, and semi-metals. Most metals are shiny, right? Generally, metals are shiny. Now, metals are lustrous. So lustrous and shiny, they mean almost the same thing. Then metals are malleable. By malleable, you mean being able to beat the metal or being able to beat the substance into different shapes. For example, this container is made of metal, right? I may decide to change the shape of this container, right? So I can beat it, I can apply pressure. And if I apply pressure, for example, using a hammer, I can convert this shape into something else. So in a way, that is what malleability means, being able to beat the substance into different shapes. So then the next property of a metal is ductility. So metals are ductile, and I will use this cable as an example, right? You can see this strand here. Okay, so this strand I'm holding, right, or this cable I'm holding here is made of metal. So you can see the metal here, right? So we can see that this metal was drawn into wire, all right? So the ability to draw something into wire is called ductility. So generally, metals can be drawn into wires. In other words, we say that metals are ductile. Metals are ductile. You can see this, right? This metal here was drawn into this cable, right? So yeah, that is that. Generally, metals are hard. If you look at the example I gave to you previously, this is a metal, right? So it is hard compared to non-metal or compared to something like water. So metals are hard. So metals are good conductor of heat and electricity. And if you look at one of the previous examples I've given to you, this is a charger, a laptop charger, and this cable is made of metal, right? So this metal is able to transfer electricity, or it's able to transfer charge to the computer, and that helps the computer to charge. So metals are good conductors of electricity. they also conduct heat very well. A very good example of this would be the metallic pot you use in the kitchen, right? So you don't put plastic, for example, on the stove, right? Apart from the fact that it doesn't conduct, apart from the fact that plastics are poor conductor of heat, then it melts easily. So you cannot place plastic, for example, on a stove. Rather, you place a metallic pot on the stove, right? And that metallic pot conducts heat easily. So yeah, so that is that point there. And metals are usually a solid at room temperature. You can see here that they use the word usually, right? It means not all metals are solid at room temperature. Some of them could be liquid. Not all of them, not all metals are solid at room temperature. A very good exception here is mercury. Mercury is liquid at room temperature. Apart from mercury, every other metal I know of is solid at room temperature. Mostly solid at room temperature. Yeah, so I'll explain that. Now, unlike metals, non-metals are dull. They are not shiny, right? They don't have shiny appearance. Non-metals are brittle. So brittle means easily broken, easily broken. For example, this pen, or let me look for another pen. Yeah, I think I have my pencil somewhere. Okay, so this is a pencil. And of course, this pencil is made of wood, right? Wood is a non-metal, right? So I can break this easily, right? So wood is a non-metal, but wood is not an element. I'm looking for something else. If you have seen sulfur before, sulfur is a non-metal, right? It has a yellow appearance. So sulfur, for example, is easily broken, right? So it's brittle. So they are poor conductor of electricity, right? For example, yeah, they are poor conductor of electricity. They don't really conduct electricity. Also, they are poor conductor of heat. Now, non-metals can be solid, liquid, or gas at room temperature. A very good example of a non-metal that is solid at room temperature would be your sulfur, right? Sulfur is solid at room temperature. A good example of um, a non-metal that is liquid at room temperature is, let me give a very good example. Bromine water, for example, is liquid at room temperature. Let me look for another very good example of a non-metal that is liquid at room temperature. But most of the non-metals, they are gaseous, right? They are gaseous at room temperature. A very good example would be oxygen, fluorine, chlorine, and so on. So they are gas at room temperature. Now, usually less dense compared to metals. That is, they have less density. They are lighter compared to metals. Now, they are not malleable or ductile. I've already explained the meaning of malleability and ductility to you. Now, let's look at properties of semi-metals. Semi-metals are often malleable, that is, they can be beaten into different shapes. They are ductile, that is, they can be drawn into wire. They make good semiconductors, usually solid at room temperature. Usually solid at room temperature. For example, silicon. Silicon is solid at room temperature. They can either have a dull or shiny appearance. Also, it usually conducts heat and electricity, though not as well as metals. So that is a good one there. So I've shown you the periodic table, right? I'll show you periodic table. Now, use the periodic table to show and explain the location of these three major groups of elements. So the first one here is metals, element on the left side of the table, except hydrogen. So here, these ones, this group of elements in groups 1 and 2, they are metals. And remember, I told you that sometimes hydrogen would behave as metal and sometimes non-metal, but generally, hydrogen is a non-metal. Then we have non-metals, right? Non-metals. So remember, when you get past the transition element, right? When you go past transition element, then all these ones, all these elements in diagonal, that is all these elements in purple color here, they will be semi-metals or metalloids. So let me do that again to avoid confusion. So these ones, the element in purple, so this element in purple has semi-metal or metalloids, and the elements in green, these green ones, they are non-metals. I've shown you that in the, yeah, I've shown you that a moment ago. Okay, extended activities. Identify everyday use of metals, non-metals, and semi-metal, e.g. in TV set, computers, mobile phones, household items, jewelry, food industry, agriculture, and medicine. For example, here you find rings. So these are rings. So rings are made of metals like gold or silver, right? So here you have something that appears like a coin. So this is also metal. Then when you look at your computer part is made of metals, non-metal, and semi-metals. So that is a combination there. So yeah, so these are assignment. Name 5 metals and 5 non-metals which we use in our daily lives. Right? So substances that are made of metals. For example, you will think of your spoon, the spoon you use at home, the pot you use to cook is made of metal. The coin that you spend is made of metal. Even your laptop charger, the cable is made of charger and so on. Then when it comes to non-metals, so the non-metals that we use every day, very good example would be, so when it comes to non-metals as elements, very good example of non-metals that we use every day would include oxygen, right? We use oxygen for our metabolic activities. Then another non-metal we can think of will be um, chlorine. So though chlorine might not be used in everyday activity. So one very good example of the use of chlorine is to disinfect your swimming pool and so on. So you think of other examples. Now, question 2, use a blank copy of the periodic table to shade in. Classify and label the element as metals, non-metals, semi-metals based on their location on the periodic table. So you can take a cue from this table here. So you can use this example. Now, give 4 physical properties of each category: metal, non-metal, and semi-metal. So you can get that from the previous slide. And these questions you should be able to solve conveniently. It's part of the classwork. So this is a copy of the periodic table. And here we have metals. So these are non-metals. And this one semi-metals. Okay. So you have these characteristics, right? So you have to put that characteristic into this, right? Note that there are point of intersection. So this part now deals with the properties common to metals, non-metals, and semi-metals. So this is the common intersection. And here you have the intersection of properties between metals and semi-metals. Here you have the intersection of properties between metals and non-metals. And here you have the intersection of properties of non-metal and semi-metals. So you have to go to that table that we showed previously. You go to this table and you write in the properties in this Venn diagram. You fill in those properties into this Venn diagram. So here you have properties of semi-metals alone, those properties that are peculiar to semi-metals alone. Those will be the properties here. And here you have properties that are peculiar to non-metals only. And here you have properties that are exclusive or that are peculiar to metals alone. So that is that. Also, you can read your notes to answer these questions. So let's look at the practical task, investigation activities, investigating metals, non-metals, and semi-metals. So materials, iron, copper, aluminum, plastic bag, armor, safety goggle, optional is a multimeter. Okay, instruction. Investigate whether an unknown sample is a metal, non-metal, or semi-metal by using the following procedure. Describe a sample, make prediction, formulate an hypothesis, design an experiment to test your hypothesis. Then finally, you draw a table as shown below to record your result. Okay, so this is an experiment where we need different materials and apparatus to work with. All right, analyze your results and so on. So we will not be working on this for now. So we have science foundation, introduction to the periodic table of elements. So here, introduction to the periodic table of elements, good. So this is the picture of Dmitry Mendeleev, right? And he arranged the elements according to their properties in a table formed in a four-sided version of the periodic table. So during Mendeleev's time, not all the elements were known, right? But he arranged the elements in such a way that he gave a prediction of the properties of elements that were not even known at his time. And the table was known to be very accurate because scientists that came after Mendeleev, they discovered the element and the properties of the element were exactly as predicted in the spaces left in the Mendeleev's table. So it predicted them very well. Remember, not all elements were known during Mendeleev's time, right? But he left some spaces there, and when those elements were eventually discovered, then the properties of the element fit well into the prediction of this man. So it was a Russian scientist. So this is the periodic table. And as I've explained before, the elements to the left of the periodic table, the first two groups of elements are metals. So these ones that are in between, these ones, they are called transition metals or transition elements. And the elements in this yellow that form this diagonal, they are semi-metals or metalloids. And the rest of the elements are non-metals. Right? So like I told you in the lesson we had previously, when you look at your periodic table, the periodic table comprises different, each element in the periodic table, right, is unique. And for each element, we can get the name of the element, we can get the symbol, the atomic symbol of the element, then we can get the atomic number of the element. Also, we can get the atomic mass of the element, and we can get the electronegativity value of the element. In this lesson, we are not looking at the electronegativity value. We only concern ourselves with the name of the element, the symbol of the element, the atomic number, and the atomic mass. As I've shown you in our previous class, this number on top represents the atomic number, and the atomic number simply represents the number of protons in the nucleus of an atom. The number at the bottom represents the mass number, and the mass number is the sum of the number of protons and neutrons in the nucleus of an atom. So let me just write some things here. Right, so for example, in this hydrogen, the example we are looking at is hydrogen, right? Hydrogen, this element here. Now, this element, hydrogen, is in group 1 of the periodic table, right? This group, this block, this vertical block of element. So that is group 1. Now, the atomic symbol, okay, I think before we go to the group, let's write the atomic symbol. The atomic symbol will be H, right? It's in group 1. And now we can look at other details. The atomic number here, the atomic number equals this number on top, which is 1. So since the atomic number is 1, it means that it will have 1 proton in the nucleus. Remember, the number of protons the atomic number simply refers to the number of protons. Now, in a neutral atom, the number of protons usually equals the number of electrons. Now, another thing that you should remember based on our last discussion was that protons are positively charged, electrons are negatively charged, and neutrons are neutrals. They don't have any charge. Now, we've discussed the atomic number, which is this number on the top of each element. And the next one will be the mass number. Mass number. So the mass number is the sum of the number of protons plus the number of neutrons. Therefore, if we have the mass number, for example, and we have the number of protons, as we can see in these, as we can see for this element, then we can calculate the number of neutrons. So if we make the number of neutrons the subject here, it means that the number of neutrons will be equal to the mass number minus the number of protons. Right? So that is just the way to calculate it. Therefore, for a hydrogen atom, for example, the number of neutrons would be equal to the mass number, which is the number here. The mass number here is 1.01, which is approximately 1 to the nearest whole number. So it will be mass number, which is 1, then minus the number of protons. The number of protons here is the atomic number, which is 1. So it means that the number of neutrons in the nucleus of a hydrogen atom is 0. So it means that for this particular hydrogen atom represented in this way, there won't be neutron in the nucleus, right? And there's a reason I mentioned the word particular. Hydrogen can exist in different forms, but when hydrogen exists in this form, then it will have no neutron. There won't be neutrons in the nucleus of that atom. Now, let's look at another example. And in this case, we want to look at beryllium. So remember yesterday, I told you to practice with these different things. So we want to look at beryllium. So the name of that element is beryllium, right? Okay, double L. So the atomic symbol for beryllium will be Be. It would be wrong for you to say beryllium is B, right? There is another element called boron with atomic symbol of B. So, but I will show you now. You can see here boron. This is boron here. So the atomic symbol is B. So if you wrote B as the atomic symbol of beryllium, you will be wrong. That is why you need to practice with these things over and over so that you will be able to get used to things like this. So the atomic symbol of beryllium is Be. Then beryllium, if you look at it, is in group 2. It's a group 2 element. So this is group 2. Now let's examine each of these attributes. So let me see if I can copy and paste. Okay, good. So now if you look at beryllium, the number on top here is 4. So it means that the atomic symbol is 4. So it means that it will have 4 protons. We have 4 protons because the atomic number is the number of protons. Now, the number of protons equals number of electrons. It means that beryllium, the neutral beryllium atom, will have 4 electrons. So there will be 4 electrons in the neutral beryllium atom. Then the mass number, remember, equals the number of protons plus neutrons, right? So the mass number of beryllium in this case will be 9 if we convert 9.01 to the nearest whole number. So the mass number of beryllium in this case is 9. So I remember it has 4 protons. So here we can calculate the number of neutrons. So the number of neutrons will be the mass number, which is 9, minus the number of protons, which is 4. So in this case, it would be 9 minus 4, which will be equal to 5. Right? So you can try that for other elements. For example, you can try that for boron, carbon, nitrogen, oxygen, and so on. If you have not done this before, yeah, for example, Ashlume, you can follow these examples that I've done to complete the first 20 elements. So you can get a cue from Jamie's note to complete that. So that is just a simple explanation there. Now, let's look at something here. So here we have this, right? So let me just pull a line. So hydrogen finishes here. So how do we draw the atomic structure of hydrogen, for example? How do we represent the nucleus, the protons, the neutrons, and the electrons? All right, so in this case, I will just represent the protons and the neutrons of hydrogen, right? So if this is the nucleus, for example, right now, here, the proton, we have one proton. So that proton will be this. It will just be a single dot, right? So it will be a single blue dot. And the neutron is 0. We don't have any neutrons here, so there won't be neutrons here. And here, you also have one electron. Remember, the number of electrons or the number of protons will also be the number of electrons. So the electrons, they move around the nucleus, right? In a form of a cloud. It's in form of a cloud. It's not a perfect circle. So we just represent that this way. It's like a cloud, right? So I'll represent the electron with another color. So that will be red. So this will be the single electron that is moving around the nucleus of a hydrogen atom, right? Okay, so let's look at beryllium. But this one will confuse you a bit, but I will try as much as possible to simplify it. So this is the nucleus. Remember, the nucleus is the central or is the center of your atom. Here, we have 4 protons, right? So let's represent the protons with a purple dot. So this will be 1 proton, this will be 2, this will be 3, and this will be 4. So those are 4 protons, right? Then from our calculation here, we have 5 neutrons. So let's represent the neutrons in red color. So here we have 1 neutron, 2 neutrons, 3 neutrons, 4 neutrons, and 5 neutrons, right? 5 neutrons. So that would be the nucleus of a beryllium atom, right? Now, because the number of protons equals the number of electrons, it means that you will have 4 electrons moving around in a cloud around the nucleus of this beryllium nucleus, right? So here, the confusing thing here is that the nucleus, the electrons, they occupy a particular orbit, right? And the first energy level here, or the first shell, can only hold 2 electrons. So 2 electrons will be here, and the other 2 electrons will come out. So this, in a way, is higher than your level, so I won't go in depth into this. So the electrons, I will show them in black color. So here, remember, we have 4 electrons in this atom, beryllium. So the first 2 electrons will occupy this first energy level, and the other two electrons will occupy the outer energy level, right? So that is just it. But for now, I would just want us to concentrate on the nucleus, right? We concentrate on the nucleus, on the center alone, right? So for now, we will not bother ourselves about the structure of the electrons, right? So definitely you need to know the number of electrons, right, in a particular element, right? But don't bother with these rings for now. So I just want you to focus on the nucleus. So the nucleus, remember, contains the neutrons and the protons. So in this case, the blue color in the nucleus, let me just do this. So the blue dot sorry for this. So the blue dots, right, represent the protons, the blue or the purple, right? And the red dots represents the neutrons. All right, so that is the end of the lesson today.